Okay, so in this problem here, we have this quadratic equation. We know it's quadratic x squared with k's and so on. And we're told it has no solutions for this particular equation. Well, this means that we're solving for 0 for the x-intercepts. There's no solution. So if I think about like what that means, right? Like if I have a quadratic equation, the quadratic could be here, it could be here, or it could be here. When I have this scenario here, there are two solutions. Here, there's one solution, and here, this first one that I drew, that I'll highlight here in gray, there's no solutions to that equation. Like, that is when f of x equals 0 has no solutions in that gray scenario there. So when we're analyzing these solutions, we use this thing called the discriminant, which is b squared minus 4ac. In this particular problem, I know that a equals 3, b is the k minus 2, and c is the 1/4 k plus 1. And so I substitute these values all into this equation here. So I get k minus 2 squared minus 4 times 3 times the 1/4 k plus 1. And when I do this, when I have this scenario here, if there's no solutions, that means this calculation has to be a negative value. That's what this means. This means less than 0. So I'm going to make it less than 0. I'm thinking about that, but when I actually solve at this point, I'm actually going to change this to equal just temporarily. But I know I want less than 0. If I solve this equation now, I have to expand it out. I get k squared minus 4k plus 2 minus 12 times 1/4 x plus 1 equals 0. So k squared minus 4k plus 2. Distributing that negative 12, I get negative 3k, subtract 12. And then I have k squared minus 7k minus 10 is 0. And I'm going to factor this, which we've been working on. I know this is k and minus 5 and minus 2. Except I goofed here. This is actually 4 and 4, and so this value here is not. This value is going to be negative 8, and so this here is going to be negative 8 plus 1. And so k is equal to 8 and k is equal to negative 1. Now recall, I actually am trying to solve the scenario where it is less than 0, so negative values. To do this, I refer to a number line. Here's negative 1, here's 0, and here is 8. And I'm going to consider the three regions. If I look at the region over in this area here, this yellow region, I pick a number like in there, I know k could be like negative 10 or negative 2 or negative 7. If I took my negative 10 and substituted into this k, negative 10 minus 8 is a negative value. That's negative 18. And if I also substitute into here, negative 10 plus 1 is negative 9. Well, that's two negatives. When they multiply, I get a positive. I'm going to do that for each interval. When I go to this scenario, in this interval, that I'm going to refer to in green, highlighted in green, the easiest number to choose is 0. So if I take the 0, substitute it in there, I get negative 8. If I substitute the 0 into this value, I get a positive 1, which is a positive. A negative times a positive is a negative. And then finally, if I look at the last region available to me, so I'm going to do the blue stuff here. Let's pick a value in there. I'm going to say x equals like 100. Or I could do 9, but I like big numbers sometimes. If I choose the 100, substitute 100, this is definitely a positive. This is also definitely positive. So it ends up being a positive times a positive, which for sure overall is a positive. So now if we think about this scenario, it was asking us, when was it less than 0? That was what this question was saying. When is it less than 0? The discriminant less than 0 because it has no solutions. So when I want less than 0, I want negative values. That means in here, not including 8 and 1. So what I can say is, I know in words it's between -1 and 8, which means -1 is less than k, less than 8. In words, this means between -1 and 8.